In this tutorial, you'll learn about exponential functions, exponential growth, and exponential decay. So let's take a look at the formula for an exponential function. You'll notice that it has the letters a, b, and x. And this is a little bit different than a linear function, right? In a linear function, we had a y equals mx plus b. Now these letters are completely different. What b means in a linear function is not what b means in an exponential function. So the letters are unrelated. In an exponential function, the a value is the initial or starting amount, and the b value is the rate of either growth or decay. Right? So you're going to learn today that sometimes the factor or the amount of which a value is changing is either going to be increasing or decreasing. And it's not going to be so obvious like it's positive or it's negative. So you need to pay close attention to this b value today. You will be able to tell the difference between growth and decay, but you just won't be given a positive or negative value. What you are going to be given is a multiplying factor, so that's what your rate of change is today. It's not constantly an increase by the same amount. It's not constantly a decrease by the same amount, but it is constantly increasing or decreasing by the same factor, which is different. A factor is a multiplying value, all right? So you're going to have growth if your b value is greater than 1 today, and you're going to have decay if your b value is fractional, or between 0 and 1. Now remember, your linear functions and your exponential functions, they share similar letters, but they don't have the same values, so pay attention. In an exponential function, the a value, or the number without the exponent, is your initial value, and the b value is your rate of growth or decay. Take a look at these examples here. Everything on the left is growth, and everything on the right is decay. Do you notice any similarities or differences? I'm going to show you another example. Here are 6 more examples. Again, everything on the left is growth, and everything on the right is decay. So do you remember what I said at the beginning? Growth is when your multiplying factor here, or your b value, is greater than 1. It can be a whole number or an integer, or it can even be a decimal or fractional value that is equivalent to a number higher than 1, right? So it's not the fraction 1/2, but it is the fraction that's larger than 1. So fractions are okay. Not all fractions are decay. Lots of times fractions are decay because they are less than 1. Now remember, you're not going to have a negative value here. You're going to have a fractional value, a value that is between 0 and 1. Sometimes it will be a fraction, but more often than not, it will be some decimal value. So the difference between growth and decay is that the value in the b position, or the base of the exponent, hence the letter b, the base of the exponent, is a value between 0 and 1. Let's practice identifying a few. Take a look at this function. Do you think it's growth or decay? If you guessed growth, you would be right. The base value here is higher than 1, so that's growth. Let's take a look at another one. Growth or decay? If you said growth, you are right. Remember, the value inside the parentheses, or the value that has the exponent, is your rate of growth or decay. Because this is a 7, which is larger than 1, that makes this growth. All right, one more. Growth or decay? Correct. This one is decay. Now let's try one that looks a little more complicated. Growth or decay? Well, look at that value inside the parentheses here. That base is 1 plus 5.7, or 6.7. That would be higher than 1, so this is growth. Let's take a look at another one. What do you think? Growth or decay? Well, the number inside the parentheses here, the base of the exponent, which is our rate of growth or decay, is 1 minus 0.8. So that's going to be less than 1. So that's decay. All right, you should be able to easily identify now, just by looking at an equation, whether it's written in y equals form or f of x form, if it's growth or decay. Now let's identify each of these parts. Look at this question. The question is blank on the left, and it has been answered on the right. So pause the video and make sure that you can find all of these specific values. All right, I'm going to show you one more example. Pause the video if you need more time. All right, rewind, go back, look at everything, because I'm about to ask you to do this on your own. I'm going to give you some functions, some exponential functions, and I'm going to ask you to tell me the initial value, whether it's growth or decay, and what that multiplying factor is. Pause the video and answer these 3 questions. All right, let's take a look and see how you did. That third one's a bit tricky. All right, check your answers over. Have any questions for me on this third one? You notice that it has a base for the power of x, but it doesn't have parentheses or initial value in front. And that's because the initial value is an invisible 1. So that's how I got 1 for my initial value. And that's why my growth factor is 5. All right, let's give it one more try. Read these directions carefully. The first thing to write is increasing or decreasing, right? Tell me whether it's growth or decay. On the second line, state the a value, which is the initial value. And on the third line, state the b value, or the common factor, the rate of change. Pause the video and give this a go. All right, you ready to check your answers? Let's see how you did. Did you get that a value right on number 3 this time? All right, let's move along. You can have a base value or a rate of change that is actually a mathematical sentence, like this. And instead of it being a 2 or a 1.57, it could actually be this sentence, 1 plus some other number. That other number is the rate of growth or decay. The 1 here represents the entirety of the initial value. So if something is increasing or decreasing, you always start with 100% of your initial value. That's where that 1 comes from. Now, if something is increasing, you're going to add a certain percentage. And if something is decreasing, you're going to subtract a certain percentage. So notice that the only difference here are the plus or the minus signs in the middle. It's pretty obvious which one gets which. Growth is plus, decay is minus. All right, let's start using this formula here. Pause the video and take a good long look at this example. Now, I've scaffolded this question here, meaning I've given you little step-by-step parts to help you get a final answer. Notice that I've set up all 3 variables here, or all 3 inputs that you need to know. You need to know the initial amount, that's the value in the A position. You need to know the rate of growth or decay, that's the value in the R position. And you need to know the length of time, that's the exponent. Now at the top, I gave you both formulas, growth and decay. You never use both. You have to pick one. So because this question is talking about an increase, we're going to use the growth formula. Because we're talking about an increase, we're going to use the growth formula. Now let's talk about that R value. Notice that this says 9%, but my number says 0.09. That's because you can't use a percent sign in your formula. So we're going to use 9% or 9/100, also known as 0.09. This is really important. If you forget to move that decimal point and you don't have the right value, you're going to calculate the wrong response. Now notice that down here in black, I filled in all of my parts into my growth formula. I filled in 1400 for A, I put parentheses, a 1 and a plus sign, I put 0.09 for my R value, and 25 years for my T value. Notice that I then used my calculator. I typed exactly, right? I can type exactly what I see, or if I'd like to, I can simplify 1 plus 0.09 in my head. You don't have to though. You can type that out the long way. Now, because this problem is talking about money, notice that I rounded to the nearest hundredths, right? 31 cents. $12,000, $12,072.31 will be how much the investment is worth in 25 years. Whoop. I'm sorry. $1,400 in 25 years is going to turn into $12,000? That's incredible. All right, let's take a look at another example. Pause the video, look over these values. All right, did you give them a good look over? Notice that this time it's decay. All right. And that's because it says it's depreciating. To depreciate is the opposite of appreciate. To depreciate is the opposite of appreciate. To depreciate means to go down. Now notice I wrote my 12% in decimal form. And notice here, I can either leave it as a mathematical sentence, or I can simplify it down to 0.88. I didn't want to make any math mistakes, so in my calculator, I typed it exactly like the formula started. 18,000 depreciates at 12% per year. That means that the value of this car after 10 years is going to be only $5,013 and approximately, oh, I wrote that wrong. This should say, right here, this should say 2 cents. This should say 2 cents. Let me ungroup this here. I gotta alter this number. Forgot that 01. That 01 is going to be 02. 02. All right. How about you give this one a try? Okay, did you pause the video? Did you take your notes? Did you choose the right formula? Did you move your decimal point for your rate of growth? So let's take a look. Starting salary is $34,000. 1.5% when the decimal moves twice is 0.015. So when I type it in my calculator, it means that in 7 years, the salary will be $37,734.73 if you round appropriately. Remember, anytime you're working on a problem with money, you don't need to be told what to round to because money is always rounded to the hundredths place. Let's take a look at another question. Pause the video and give this a try. All right, did you pause the video? Did you take your notes? Did you move your decimal point? Let's see how you did. So the student population was 2,200 and it's declining, which means it's decreasing 0.02%, 2% means 0.02. And when I type that into my calculator, I get 1624.85. Now this is different than money. This is a population question. This is about people. So I'm not going to have parts of people, no decimals. So I'm going to have to round to nearest whole number, which would be the ones place. So it's going to be approximately 1,625 students in 15 years. All right, how about this multiple choice question? Pause the video and read it over. All right. Do you understand the vocabulary? To depreciate means to decline. So that means I should have a rate of change or a rate of decay of a number less than 1. So just by default, I know that this one is out. I also know that choice number 4 is out because it's not even an exponential function. And anything that grows at a percentage or declines at a percentage is always exponential. So the question is it 0.14 or is it 0.86? So let's think about this. Well, I have 100% of my value and then a decrease of 0.14, and 1 minus 0.14 is 0.86. So the answer was 2. All right, that concludes this lesson. Let's see how much you understand. Try this exit ticket before you end the video. All right, you ready? What does 1.02 represent in this equation? Well, the number is higher than 1. So decay is definitely out. The question is, how much did it grow by? Now I know the number says 0.02, but that is missing a percent sign. So if you want to put the percent sign back in, you got to move that decimal point back over. So the answer is 4, 2% growth. And that concludes the lesson on exponential function basics.